Building a robot is easy on paper, but making one that actually moves, thinks, and interacts with the real world, that's where the things get messy. I am Puya, and I have a dream to build a robotic companion for my dog, Jimmy, and myself. I know the AI, I know the control theory, but there is a massive missing link in my skill set. I have designed CAD, I have designed the brains, but I have never touched the physical simulator or ROS. So I am going to learn this stuff, and at the same time I'm going to share it with you guys, to whoever could be interested and wants to follow along the line with me. So don't expect anything polished. And also, this is my very first video and content creation experience, so it will be a messy video. So there will be a lot of tries and errors. Something won't work, and I hope finally we get something work. So I have designed the CAD files, as I said, but in order to really create and build a robot, we need to start with simulation and find out all the shortcomings, all the advantages, optimize the model, edit it, and then create the real robot. So I don't know how to exactly, I don't know how to get my CAD model into a physical simulator, make it move, run, and then connect it to the ROS to control it. Then I will be designing a brain, of course, for the robot. And to fill this gap, I'm going to learn and document this series and share it with you guys as I go. So let's dive into the things. Let's go here. So I will start very simple, and I will start very simple. So I don't want to create a very complex CAD at the beginning and get the mistakes of that parts. So I have downloaded very simple manipulator to start with, and then I will use the FreeCAD software to import the things and import the model into it, create the constraints and everything. So I did a research on how should I implement this, and I come up with the idea that I need, of course, a CAD model, which I have downloaded here. Then I need to assemble different parts together. So every CAD model, as you know, is a file that contains the shape of different components of the robotic or mechanical system, but they are not necessarily connected to each other, and they don't know how to move or connected to each other. So I have to let the model know how they are constrained to one another, and then make the movements. And I learned that I have to create a file named a URDF file, which contains all the necessary information for a Gazebo or a Mujoko system to understand the model and their connections between them. So let's dive into it. As I said, I have downloaded this model here. As you can see, it's 3DOF, I think 5DOF actually, model UR10 arm. So I will start with this to be simple. As I said, I have downloaded the file, and let's dive into it and import it into the FreeCAD, and let's see how it goes. Okay, let me see if I'm recording actually. Okay, yeah, here we are. Let's see. I have downloaded this thing here, so the file should be here, and I will need to import this document. Open this document in the FreeCAD and see what it has in it. Okay, I didn't expect this. It's a bit heavy file, or my computer is going kind of crazy, maybe? Okay, here we are. Okay, so this is the model. Let me see how to rotate it. Okay, so yes, this is the CAD file essentially. So this is also my very first time using this FreeCAD. I was used to use softwares like SolidWorks and CATIA, but the FreeCAD I don't know exactly how to work with it. Let's see. Okay, let's save this file. Let's go to desktop, create a new folder, ARM assembly, and that's it. Test 1. Okay, so here we are. Let's see what we have in this tree. Okay, so we have different components. As you can see, we have the base, which is here. This is the connector to the disk or whatever. Then we have this motor connected to it, which I think is rotating around the z-axis. So if this one rotates, everything above it and attached to it will be returning. Then we have the second motor, as they call it, motor 2, which is connected to it, and I assume that it will rotate around this axis and make everything upward and attached to it. Let's see why this is my computer going crazy, I think. If I close the VS Code and the other unnecessary things, so okay, this is what I told you about. It will be a messy tutorial. Don't expect anything polished as opposed to other kind of videos. Okay, here we go. So then we have these different links. Let's see how we can model it. So I will go to this assembly part and see if it contains anything here. So I am going to create a new document and call it, let me save this, assembly test 1. Let's see how it works in FreeCAD and how I'm going to do it. By the way, I will be sharing the I will share the polished files when it's finished. So in this video it would be trial and error until it works, so it will be a messy, but at the end I will polish the video, edit the video, and just share the necessary parts that had worked after the trial and error. So let's see, how can we, so in order to, okay, let me explain the CAD a bit. What is it? So as I said, the CAD file consists of different components of the manipulator or the arm, and we have to kind of let the model know how they are actually connected. It seems they are connected to each other, but they are not. So they are just positioned besides each other in normal way, but in a logical way, and it seems right, but actually it is not. So as you can see here, you cannot see anything named assembly in this model that we imported. So we need to create this assembly file. And let's see how we can do it here. New assembly. Okay, and here we go, a new component. Okay, I will import this. Okay, okay, that's it. No, this is the origins. So I need to kind of bring all these components into the assembly and make the connections. Let's see how it works. Okay, let's go to the assembly, and what does it say? Component. Okay, yes, I want this component. Yes, I don't know what it says, but okay. Okay, finally. So we imported this base into the assembly, and it is shown with a lock, which I suppose that we cannot move it. So let's import the other parts as well. We go to insert a component. We added a base. Let's add this, insert that, and all other parts as well. Right. Okay. Yeah, good to go. So we have everything in the assembly now. Okay. Okay, base. Let me see if this hide. Okay, so let me hide it, hide the rest of the part for now, and start with the base that we're going to work with. No, actually it's not. Okay. Well, everything is duplicate now. No, I did something wrong. Okay, these parts are movable, but this one that comes from the original model that we imported isn't working. So, okay, and this also doesn't move. Let me see if I can do something about this original model. Can we delete it? Oops, everything deleted. Okay, something went wrong. Let's start over. Okay, I had created this one, so let's import something here. Okay, we are in assembly, and I am trying to add a part, not like this. Assembly test. Okay, component, and now we should be able to kind of import these models in it. No, we are not able to do that. So close that comment. So close. What would it have here? Close document. Discard everything. Okay. So close everything and start over. I don't know what I did wrong, and I will start again. Let me move the files wherever they were, and okay, I will just we have the SLD parts, which is SolidWorks individual parts, but unfortunately the FreeCAD is unable to import it, so I only need to bring this one and to okay, so here we go. We go to open UR10. We're going to open it again. This takes time. Okay, here we are. We have this. Now, what new part? No, new assembly. Okay, so we created a new assembly and we have to add new components into this assembly. You want to ground the first inserted part automatically. You need at least one grounded part in your assembly. Yes, I do want it. Okay, then we will add the rest. Okay, and that's it, all inserted. Okay, and now we have all the things, all the components under the assembly branch. Now we need to, let me see if I can hide the original model for now. So everything here is from the original model that we imported is hidden now, and we only have these movable components that we need to work on. So for now I will also try to make here a bit clean and hide the other parts. So we will be starting with, okay, so okay, this is the first. So first of all, this motor is connected to the base and it is rotating around this axis, I suppose. And we need to create the constraints and let the model know that these are connected and rotating. So this is a revolt joint. So I'm going to select this. Maybe control, rotate, not this one. Rotate this a bit, select this. Rotate, okay, wow. Let's select it. Okay, this one, okay, mode from motor, and also control. Okay, so now we have selected the two surfaces, two circular surfaces from two things, and I need need to add some joints. So this is a fixed joint, which is not. This is a revolute joint, which is what we are looking for. Okay, nice. So now they're connected to each other. Motor 1 face and base 1 face. Okay, let's see. So they should be moving. Okay, nice. Nice. So we have the first component connected. And now if this is stationary, static base, and this is the motor that is connected to the base and rotating around it. So let's go to the next one. So this is motor 2. We need to do the same thing. So this motor will rotate around this axis, and so we need to make it a revolute joint. Okay, motor 1 and motor 2, again a revolute joint. Okay, now they're connected. Let me see, check it. Okay, it's moving in the right direction. Now, good. It's going better than I expected. Now let's go to the link. So this link will be connected to this area, but it will not rotate around it. So this is a stationary, I suppose, with respect to this motor. And if this motor rotates around this, it should be rotate with the motor as well. Now we have to, I think I have to select this surface, rotate it, control, and this surface as well. Okay, so now fixed joint. Let me try this. Okay, that is good. Okay, that's fixed. Okay, if we move this, that's moving. Correct. Done. And the rest. Let's this model. Oops. Okay. Also here I can see some screw holes. So this motor's rotor, as I suppose, should be in this direction, rotating the rest of the arm. So this surface and this surface should be connected with a fixed joint constraint. And let's check it. Okay. Oops. Where did it go? So I think, yeah, that works good. So with the rotation of motor 2, everything above it will rotate, and I think we're good to go for now. And then we have another motor here. So let's see how it's supposed to work. Okay. So this motor is rotating. This motor means motor 3 is rotating motor 4, which is this one, and let me rotate this thing. Okay. It should be like this, yeah. Again, let's let's move it in this direction. Oh. Okay, so they should be connected, but they should not be fixed with respect to one another. So I will select both surfaces and we'll connect them with the revolute joint, which is like this. Okay, I think we're good. So this is rotating around this axis, which is the z-axis here. Let's see. Okay, everything is moving. Okay, this is rotating everything. So now we have the model getting a understanding of how it is supposed to work and move. Okay, let's do the rest. Okay, we have the next link here, link 2. These links should be okay. Motor 1 was rotating this motor, and since this is a motor as well, I think it should be connected to this with a revolute joint. So I will be select. Okay. Okay. I'll select this motor, rotate the model, and select this surface as well. So the two surfaces from motor 4 and the link 2 are selected. Let's make them a revolute joint. Let's see. Oops. So it is connected, but in a wrong direction. It should have been connected in another direction. Let me see if I can edit. Is there any edits here? No. Do we have a control Z? Okay, we have the undo here. So I will do a couple of undos. Okay, nice. So that was wrong. I didn't know how to fix it. So we have this working. Let me rotate it a bit to be more aligned with the joint. Let me move it a bit here, here, okay, and here to make closer to one another. And in this direction, here, okay. So now I think we can try. Okay. Where did the other link went? Let me again bring it closer. Now let me select this and select this surface again and do the revolution. Okay, I think it's connected now. Disconnected correctly, so yeah, it is moving with respect to this motor. It's rotating, so I think we're good to go now. This is like this. If I rotate this from this area, it moves, and all the things are moving as expected. Okay, good. Let's go. We have another motor which will be connected to this. Let me see how many components we have left. 2 motors and a bracket. Okay. I think I have to move this a bit. This is bothering me. I don't know why this pops up. Okay, let me bring them closer to each other so that we can see what we're doing. Let me rotate it a bit, see if they're actually close to each other. A bit around here. Okay, I think that's good. It's aligned well enough. Let me see this from another area. Okay, this is the end. First, let me rotate it a bit in this direction. Things. Okay, so this is a motor and this is the link. They are supposed to be connected via a revolute joint. Let me grab this surface as well. So the surface is from motor 5 and link 2 are selected now. I'm going to make them a revolute joint and see if it is doing what it is supposed to do. Okay, yeah, good. Okay, and the next one. I have lost, well, we have 2 motors left, so it's a 7DOF model. I thought it was less and less complicated, but anyways, we started and we will continue with this. Let's move them closer to each other. Okay, so we have this motor and the other one. I will connect. I have to still rotate this one a bit. Since you know the back of the motor, back of this motor 6, sorry, is here, and the back of the motor 5 also is here, so they cannot be in the same plane, or their rotors cannot be in the same axis. So I think I need to rotate this a bit and okay, go all the way here. Okay, now I think it's better. Now let me check the model itself. Yeah, back of the motor is here, and the back of the other motor is connected to this one. I mean, is facing to ground, so that's okay. Now I'm going to select this surface, and this surface, and make them a revolute joint. Oh, nice. Nice. Isometric fit selection. Okay. Fit. Align the selection. Fit all. Okay, no. Let me move this a bit and check it with the model that we downloaded if we're going. So I have this one here facing upside, and this one in this direction, these two facing to each other, going up to the next 3 motors. This can move here to be along like that, and this have to move upwards. And now, okay, now we're assembling it well enough, I think. Let's go to motor 7. Where is it? Oops, it's on the other side of the world. Let me grab this thing, try to get them closer. Okay, and if I check, it should look on that way. So I don't know how I'm supposed to. Okay, rotate this along this axis and also a bit here so they're aligned well. I will select this surface and this one and make them a revolute joint as well. It's working. Yes, and we're good. Okay, and that's it. Oh, the last one. So where's the last one? Again, on the other side of the world. Come on, man. Okay, are you close or not? Okay, this is the bracket where the end effector or gripper or whatever will be connected to. So this motor will be rotating this one, and then so we have to make a revolute joint again and then everything moves radically. Okay, let's see how it works. Oh, nice. Now this should rotate around this, yeah, which is, now we're good to go. Nice. So I think we're going fast. Let me save this before I lose anything. arm assembly. Here the name. Now let me check from fit all. Yeah. Okay, well, let me check. Let's check all of the links and see if all of them are working fine. And then we should be here. Still not used to these mouse commands in FreeCAD, so they're jumping. Can I move this a bit? Okay, now it's more clear. Now, if this motor rotates, every single bow and connected to it will be rotating. Then we have this motor, which should be rotating. No. Why? They were moving, but not anymore. Okay, it's moving. Now, if this moves, every single bow and connected to it will be moving. Then we have this one, which is a fixed one as well. At least we made it fixed. Now, I have a doubt here. This seems to be a little bit wrong, I think. Let me check it with the document. Okay. Here we go. Which way I can do it here? What's this? Let's go to the file and I'm trying to go to this file and see the actual rendered images. So this is facing this way and these are facing towards one another, which I really don't know why they do. You know that I doubt about one thing. So I have not seen the real robot, but from this CAD file, these motors seems to share the same axis for both motors, which is kind of weird. So the both rotors of the both motors are connected somehow. I don't know why it should be connected. Let me see if, yeah, both of them are called a motor. Okay, anyways, I think there's something wrong or not. Even if it is, you know, the shaft of these two motors, the axis of these two motors are aligned with each other. When you look to the end of these motors, the back of these motors, they're in the same plane, which is kind of weird, but anyways, the functionality doesn't change. So I suppose that this motor will rotate this one in this direction, which seems to be correct. And then we have this motor, and this one will rotate. No. And we have another motor here, and we have another motor here. So, okay, I have done something wrong. These two motors, so this motor is responsible to rotate this link around this axis, and this motor, which is called motor 5, responsible to rotate around this axis. This is turning around this. This is turning around. Okay, let's just start from this part. This motor rotates the bracket. This motor itself is rotated by motor 6. Motor 6 is rotated by motor 5, and motor 5 is rotating this one. True. And this one. Let's see if I can find any kind of writing here. Let me check here. I think the CAD model is from this one. The CAD file is a single part. I modified the CAD and made the assembly where all its arms are moving. I have omitted bolts. The problem with combined function and SolidWorks. Okay. Very close. And okay, it misses the link UR10. Yes, I think this is it. This is the original model that it comes from. Let's see if it loads. Whoa. Okay. Six rotating joints. Let's put it on here. I don't have an account here, so the model is not loading. This is upwards, this one here, and we don't have this. If it's easy to big thing. Okay. doesn't make sense. So if I start from this part, this motor is either rotating around this axis. I don't know which axis is this in this area. So either it rotates around this, which is correct, which is as it does right now, and seems to be correct. And this one is connected to this and rotates along this axis, which also seems to be fine now. So this one should be fixed to it, and this motor is supposed to turn around everything is moving. I think we're good to go, but I want to make sure that we don't repeat anything. This one is correct, both from the look point of view. So we have the motors back here, which is supposed to rotate this bracket and end effector. Okay, so this part should be stationary and would be rotated with this motor. So each motor could only have one rotating axis, one rotor. So if this is the rotor, this part should be stationary, which itself is rotated by this motor. Okay. Okay, this is moved by that motor. Check this one again. Seems right. So this part should be stationary and connected to it, which seems to be correct. No, it isn't correct. So this motor is rotating the rest of the parts, and it cannot rotate most of it. So let me change one thing. So let me see, where are our links joints that we created. Okay, so these are the joints that we created. Let me see, this is the last one, and the last, this one, and this one. Okay, this is the joint between this and this, which seems to be correct, but this one should be fixed and not rotate with respect to this link. So which one it was? No. Okay, so I am going to let me save this before I make any trouble. Okay, this one, labels, angle. Can we change it or can we delete it? Is there any edit? Guys online, anyone seeing this and have any suggestion and experience with this FreeCAD software? Let me know, please. I'll delete it. Okay, so now we can move it. Now I am going to create a new. Where did it go? And this surface should be connected with a fixed link. Okay, if this moves, everything above it moves as well, which seems correct. Now we're good to go. Okay. So I think we have everything so far, and we are good to go for today. I'm working on this as a little side project, so I think that's enough for today. We have imported the CAD file into the FreeCAD, which I choose the FreeCAD for, as it is a free software, and I will be sharing all of the code, CAD files and anything along the way with you guys, so you can make it for yourself and use it and follow this series. I'll be glad to have you in this series with me, and let's learn to each other. For those of you who are new, please follow and subscribe to see the rest of the thing, and for those more experienced, please put in the comments if I'm doing anything wrong or if I'm following the wrong path, so that before making we can do less trial and error. That'll be great. So I will save this file, and tomorrow I will post working on the URDF file. So we had downloaded the CAD file, and now I'm going we created the assembly file together. So now we have the data on how the different components of the model can and should move or rotate with respect to one another. And now as I found out in the research that I did, we need to create a URDF file in order to be able to move it to Gazebo and make the real physical simulation there. So for tomorrow we will try to create this URDF file, and depending on how fast it goes and how easy or hard it is, then we might be able to even implement it start the implementation in the Gazebo as well. So see you guys tomorrow. Follow for the next steps, and drop comments if you have any questions or have any suggestions on